here, but it's easy enough if I can figure out what that angle is. Law of sines?
You lost me.
How do you want to solve it? How do you want to solve for this angle right here?
Science.
Pardon?
Law of science.
Okay. So it's IC over the sine of, we'll call this phi 4, over the sine of phi 4 is equal to, I guess I have that angle right there. So IPS over the sine of 0.72399. I know IC and IPS, those are over there. So sine of phi 4 is, multiply the diagonal, you know, so that's 12.7954 times the sine of 0.72399 divided by what's left over, 8.7297. And ultimately you get phi 4 equal to
0.9704.
9704.
Yep.
One more.
.97087.
You got 87. Did you both use 72399? Or one of you use 72400?
72. Did you use the same value that's not rounded?
I don't know. I didn't round any of my intermediate steps.
72399.
Yep. Yes.
I kind of did it.
Hold up.
Did I just write a number?
I don't know. I kind of did it backwards of that. Like I took the inverse of.
I got 0.9708.
Hold up.
That's two of you.
7.
You got that also?
Yeah.
Okay, so that's 3. Now, realistically, on a quiz or test, would I notice the 0.9704 versus 0.9708? Probably not.
Yeah, I wrote it down as 5 instead of a 9.
Okay. What, one more digit?
7.
Yeah.
87? All right.
So now it's the inverse.
So-
of that.
Let's think about what we have here. We got IPS like there. We have that angle right there is what we just figured out.
No, it's we got sine of phi
We got-
4.
Oh, you haven't done the inverse sine yet?
Yeah, so it's 1.3288.
1 point.
3288.
Oh. That's one big, yeah.
All right. So this angle right here, so this is my IPS, this is my epsilon sub naught. That's the angle we need right there. Try to keep it. I'm not blocking people. And so this angle right here is 1.3288. We know this angle, that's phi 1.
Yep.
0.84679. Therefore, what is this angle right here?
0.48205.
0.48205.
Yep.
So I can now put in this last piece, we can check it, and we'll find the mistake. So what is this, what goes here?
Plus 0.48205.
All right. In theory, we're done, we can be happy, but we are gonna check it because there is a mistake. I got this far. I solved this 2 different ways, came up with, I agreed on everything except for one of these numbers. Anyone see the mistake before we actually show that there is a problem? All right. So let's use the time when the voltage from the power supply is at 5 or 6 radians, 30 degrees, whichever way you want to go. Which, in essence, we're asking, what is omega t equal to pi over 6? And that's going to occur at 1 over 720 seconds. And the reason why I jumped straight to that as opposed to letting you go ahead and calculate, you'll get whatever that is in decimal form. But this is a rounded off number right here, so if we had used this value for omega, it would have been rounded off, and it like comes out, I think, nicely. It's just a simple fraction. All right, so at time is equal to 1/720th. What are my values?
I got 146.9.
For the first one,
Yes,
146.
9697.
Same for the second.
Oh, good, I hope so. Units,
Volts.
all right.
For the next one, I had 106.58
106.58.
volts.
The next one's 40 something, 40 point something.
$40.3784.
All right, so we can do our first check right there, that the voltage, the potential difference between the bottom junction and the top junction should be the same regardless of the path. Well, across the power supply, we got 146 point, just shy of 147. Across the capacitor, just shy of 147. Up the middle, should just be the sum of those two. So it comes out, as you can hopefully see, pretty darn close to that.
Mm-hmm.
So, feeling good about that. Currents.
7.106
So-
amps.
8? Oh, amps.
No, amps, yeah.
Give me one more decimal.
0, 1,
Oh,
yeah.
106. Oh, okay. I apologize. I didn't realize you had already given me the 0.
For the power supply,
Yep.
4.6751.
4.6751.
Yep.
And IC.
Negative 6.3977.
3977. All right, so let's do that check. At the top junction, I have the current coming in from the power supply of 7.10601. So at that top junction, I got 7.10601. From the middle one, if you're sort of thinking of the flow going like that, flow going down, we got a positive number there, so I've got, oh, wrote the wrong number there. Power supply was 4.6751. Flowing down, 7.10601. And then for the capacitor, I got a negative value, so that means it's flowing this way, 6.3977 amperes. So is the current flowing in equal to the current flowing out?
No.
Fortunately, you will not have to spend 2 hours trying to figure out where the mistake is. However, I would like you to spend some time figuring out where the mistake is. This worked out nicely, so I'm figuring we're pretty darn close here. And I will tell you the problem is with the power supply current.
Was it bad math?
It was not a careless error, it was an oversight.
Is it anything with our equation?
Not,
Is our equation correct?
the format is, one of those numbers is not. I'll go ahead and tell you, the phase shift is off.
That's what we did.
This is, law of sines is the side length over the sine of the opposite angle, so I had IC over the sine of phi 4,
Oh.
and IPS over the sine of the 0.72399. Multiply those, divided by that, get me this. Several people got this answer. I mean, there was double checking going on.
You rather get the inverse sign, so.
We did.
And so we get inverse sine down to here,
Right.
and I think on the calculator, the inverse sine gets you that.
Yep. And there's nothing wrong there, or,
It'd be right over there.
yeah.
The problem's over here. You know, there's part of me that's feeling a little bit glad that no one said, oh, well, clearly it, and then just said what it is, so I'm in good company.
Well, we put our calculators in radians.
It's not, I'm trusting that your calculator was used properly.
Okay.
I don't think there was a mistype or anything like that, or several people made the same common mistake.
Like a puzzle now.
Is it the way the equation the phase is set up? It's supposed to be?
Oh wait, this is set up? Or-
I guess down below, yeah, that one.
No, I don't think there's anything wrong with that.
That's not right, okay. I'm sorry.
Let's solve for phi 4 a different way. Let's use law of cosines to solve for phi 4. Using law of cosines, so I'm looking at this triangle right here. The opposite side, since we know all those values, this is a whole lot simpler than before. So we have IC squared is equal to, IC squared is equal to IRL squared plus ITS squared minus 2 times IRL ITS cosine of phi 4. All right, feeling good, I wrote that correctly. We know what IC, IR, we know what everything is here except for phi 4.
.8128.
Any confirmation on that? What is that in degrees?
I got 1.328.
You got what we had before? That's unexpected.
It really is.
Did you, when you divided here, did you divide by the -2?
That I didn't do. Yep, I didn't do that. That's probably why.
By the way, that's a hint what the problem was. All right, so what is this in degrees?
Is it 103.865? Is that what you're looking for?
103.685?
0.865.
865, 103.9 is probably good enough for what I want to do right here in degrees. And what is the 1.3288 in degrees?
1.82, yep.
All right. You got that?
76.135.
Say it again?
76.1.
What was the problem the first time through?
The negative sign.
There's no negative over here. First time through, there's no negative to deal with.
Yeah, put a negative over there.
Should
I guess we didn't use the log signs right exactly, or?
How do we misuse it?
Tell you right now that IC over sign epsilon 4, that's
This is actually correct. That's not the problem.
real,
Our
okay.
problem was in this step right here.
That's when we say we have to, oh, we use cosine, oh.
Yes?
We use sine
Yeah.
instead of being cosine. We're supposed to do the inverse of cosine.
No, inverse sign was right.
Is it the fact that it's 0.97, we don't know if it's going above or below the axis?
Oh, your spirit is right there. When I have a unit circle, the sign tells me which value.
The Y.
Oh.
I have two angles, which will give me the exact same sign value. Two angles which are possible for a triangle. The way I drew it here was based upon purely my guesswork about the size of these vectors. I don't know what the size is when I'm drawing my phasors. Sorry, I meant to say phasors before instead of vector. The calculator tells you this angle right here,
But not the,
that's the actual angle involved here. Now, while cosine doesn't get fooled by that, because if we had ended up, because presumably you had cosine of 5/4 is equal to some negative number, which is a second quadrant angle. Calculator's not gonna give you a third quadrant. So this should be 1.8128, which changes this number to 0.7 something. Can't even read my handwriting. Oh, there we go.
Would it still be, would you still subtract 5.1 from it?
Yeah, oh yeah.
So it wouldn't be the 1.
Oh, thank you, you're right. So the 1.8128 minus 0.84679.
0.96601.
Now, if you crank through it, 0.7 something.
.70797.
So now if we look at that our current coming in from the power supply, 0.70797. I have roughly 7.1 coming in, I have 7.1 coming out. We get our final check. Yeah. The master set question from that chapter. Yeah, it's different, but that's the breadth of work.
Is that the only question on there for the master?
I broke it down into a bunch of parts, but yeah, it's basically, the final question is, what are these? The first part is, I think, basically this section right here. The second part is draw the phasor diagram. Third part, I think, coming up with the values, and fourth part, writing down the equations.
Cool.
Which chapter is that? 33?
30,
133.
33? 32?
32
No,
is the one
33,
we do in
we
2
just did the
days.
quiz on 32.
33.
I have a book here. 33 is the inductors and AC circuits. All right. Any questions before I do the exact same problem a different way?
Is the second way that you're about to show us easier?
Some people think so.
Okay.
Personally, I do too. Now, if I started out with the first way, there's a certain amount of hand waving that I have to do unless I went through some of this. I'm gonna skip some steps because we've already justified a good bit right here. I am gonna hand wave a little bit because of the time. But any questions before I erase?
Is there just as much geometry with the other way?
I would say no.
Okay.
Oh, true.
Then I'm leaning that way.
We'll be dealing with complex numbers.
Okay.
So if you hate complex, if you have a fear of complex numbers, then it might not be the way for you. All right, some of the information is still the same, but we'll do these from scratch. We're gonna keep those up there. Omega still that, let me just pull it off to the side here. So omega 376.991 radians per second. Epsilons of naught, 0.689.706